Hello, I'm Ricky and welcome to the Dev Method. Today's episode, we're going to be taking a look at arrays. We're specifically going to take a look at map, reduce, and filter, and how they're implemented and how you should think about them when using them inside your applications and programs. So the map, reduce, and filter are methods on the prototype of array that are going to help us essentially make less mistakes in our code. And I will show you why. So the first thing I want to review with you is a traditional for loop. And some of the people in the community call this a C-style for loop. So let me show you why. So let's say we have an array. Let's do my array, or I'll call it, I'll call it items. Okay, and it has R, I, C, K, and Y, right? And I want to loop through each one and let's say console log them. So in a C style or a traditional for loop, we would do something like for, and then we say like so. Right? So let's run this with Node. Save the file. So one after another, it prints it out on each line. This is what would be our traditional for loop. Essentially, we have some sort of like initialization, then we have a conditional check of some kind, and then we increment that index that we initially initialized, and we go ahead and index into the array. So this is array 0, this is 1, 2, 3, and index 4. So 5 items total, prints out each one of these. Let me just show you one more time, but with the indexes of each one. So 0 index into that array is R, and then I, and then 2 is C, and then so on. So you might think this is all you need. Now, there are some issues with something like this. Let's say, for example, we wanted to loop through everything in the array, but let's say for some reason somebody 50 lines up into our file declared I, and then we go ahead and declare this like local I. So with this let keyword, it actually is for local scope in this block of code. So it actually still would work. So the issue here is, and you might see this a couple of times, that the incrementing part is the tough part. So it could be that maybe, I don't know, you get a programmer who does something like this and does this, and then at the end they want to console log I. They might think, oh, okay, I is 9. So actually I is 5 because on that last exit, incremented one more time, then it checks the condition. And then here we have our console log, and that's why we equal 5 at the very end. So I guess what I'm trying to say is that there are a lot of different variations of declaring variables, and for you to iterate through everything seems like a lot of boilerplate, right? So this is just a very simple contrived example, but we could have something like this here, where it's like an object, and this object has like 20 different things that are properties of it, like it's got a name, it's got an address, and all this other stuff. So let me just show you here. If we were going to loop through this, we'd actually still get very similar output. Let me show you what it looks like here. So now it prints out each object along with the index. Let me take some of these things away, because the real focus here is how do we get rid of this like I thing, right? Because what if, for example, we wanted to say anything that is equal to the name being I. We would do if items of I equals, well actually, let's do C. We'll do C here, because we're already using I up here. So let's say we wanted to only print out things, or actually every time that happens, we'll say print a emoji, like this smiley face guy. Found C. All right. So notice here, we didn't find it because we have to do this dot name, right? Let's do that again. All right, so found C, and then continued to print it out. Let's say we do this, take that out, found C, right? Now, what if we wanted to take these items and make that previous array that we had? So we have R and just I and just C. So every name, so essentially we'd have in the end transformed items, and we would want something like this equivalent. Right, that's our goal. And so instead of console logging and doing like a conditional if statement here, let's say we did transformed items dot append. We want the items I dot name, right? And add them to this array. So I'm going to erase the elements here so you can just see that this is what will happen after we run it. Oh, made a mistake. Oh, because it's not append, it is push. My bad. Oh, and then console log items, then console log transformed items, right? So here's the initial items, all the items in that array, and then we have transformed items. So besides like the printout here that we got that's in a strange format, essentially we're just taking each one of these elements and like grabbing a property from it, or grabbing a value from one of its properties, and we're just creating a new array from it. So it's a very common use case in programming to be able to do this. So you want to take all the names and just print them all out on screen. That's what we're doing here. Maybe it's we want to get all of the ages and we want to add them all up to see how many total years we have. Or maybe it's like a dollar amount. You want to add up everything in the list. Or maybe you want to take everything that's a negative number and exclude it from the list, right? So let me actually do that one. So I'll just give these random numbers. Negative 99, 100, and let's do 0. So if that item dot name is less than 0, then we will push it into this list. Right? So what should we get? Yeah, the transformed items only give us the negative numbers, right? So I could actually say that this is only negatives. Okay. Oops. Oh. Got one more thing here. So only the negatives are in that list. So this combination of traditional, like a C-style for loop, as it's called, you can make mistakes with this. As you can see, like I'm creating a new array, and then I'm like pushing new items onto it. It's not as easy as what you might think. Like this seems pretty easy now that you're looking at it and understanding what we're trying to do. But it's very simple to make mistakes. There's a lot of things you have to worry about when it comes to balancing the eye, making sure that does get increased or doesn't get increased. You might mistake depending on, how big this is, but it's like way down here. You have a lot of logic to determine like, does it go in the array? Does it not? Also, what if you wanted to like filter these things out and you weren't pushing in like, say, the name? You just want to filter out all the objects that have that. And then from there, you want to then also print out, say, like, I don't know, like let's do something like color. Color, let's say red. Oop. Whoa, long array. Okay. So as our objects change and morph, the code actually gets a little bit tougher to read. As you can see, I'm like starting to get to like 17 lines, right? So this might be quite a few lines for you to do to be able to just like filter out everything that's negative and then push that into an array. And then let's say if after that, you have another step you want to do. You want to then put all the colors that, start with W or something like that. So you would maybe put in like, and if the items dot color like starts with a W, right? And then put it in there. So if we ran this now, we actually get nothing because there's nothing that's below 100 or I'm sorry, below 0. And that the color starts with the letter W. So this gets a little unwieldy, having to filter things out and like expand this if statement. This gets really complicated really fast. So it's easy to see a small example like this, but on bigger maybe projects or bigger problems that you're trying to solve, this type of like boilerplate code can easily be mixed up and messed up. So I want to show you something a little bit better and a little bit different. So let's take a look at a new file. And we'll look at the map. So I'm going to take the same array. Actually, I'm going to take the whole thing and we'll refactor it just for map, right? So the first step is just to get all the items that are the 0 here, right? So what we can do is we can do a map. So get only the negatives, right? So I would say items.map, and then give it a function, an anonymous function, that returns another item of some kind. So for right now, let's just say, return an emoji for every single item that's in the array. Let's do the recycle one. Ooh, that doesn't look good in this font. What's another one? What's a good one here? Soccer ball. All right. Okay. Let me comment this stuff out. And now let's do map. So as you can see, for every item that's in the array, I just created a soccer ball. So that's kind of the equivalent of doing something like soccer ball. Here we go. So notice the difference here. This type of style is a lot more succinct. You don't have to balance this integer, and you don't have to say the condition that you're looking for, and you also don't have to increment the integer or forget incrementing the integer. Because there's a lot of different ways to increment an integer, right? So there's the plus before, and then there's the plus plus after, oops, like I had before. And there's also like I plus equals 1. It's another way to do it, right? So this idea of being a little bit more succinct about how you're creating your next array or your next item can be a lot simpler. So like in this case, let's just take all the colors. So I would just say, this is my item itself. So items is the whole, all of everything. And then we would say item.color. And then let's print that out. So here we go, all the colors, right? The reason you want to do this is to eliminate balancing that initializer, the condition, and then the incrementer at the end. Or like, how do you how do you keep balance of all of those things in your head while actually just trying to do exactly what this map function does? So this map function, this anonymous function that we gave it, doesn't have to be declared just like this. So you can say the map transform equals this, and we can pass this in as like a variable. So that's actually pretty cool, because in a language like JavaScript, you have functions that can be passed around as parameters, or as they could be assigned to variables like so. And you can pass in different transforms for this map that it has to do. So you, as the user, can define many different versions of the for loop. You don't have to keep writing those C-style for loops over and over again. You could write a couple different functions and then pass in as a parameter to map which function you want to run. Just for those of you who have maybe looked at more recent versions of JavaScript, there's also these concept of arrow functions. Works the same way. Just to prove it to you, I'll run it one more time. Got the same results. So that's our map function. I use that one a lot. I like it. I don't like writing the C-style for loops, because this not only looks cleaner, but I can understand like what's going on here. For the most part of what I see, and again, this is just me, not necessarily everybody, but I usually see people doing them like this, like as like anonymous functions, or like these closures, right? It's up to you how you want to do that. I think in the older, before like ES6 JavaScript, where we had just vars, we didn't have lets and const. This was actually a really cool thing to do too, because we would have had like function scoping with just vars. But with the introduction of map and whatnot, and we have like, the const and let, it's not as big of a win with something like that. But that is something to also keep in mind, is this is one of the newer features of JavaScript. Probably not necessarily just new anymore. It's within the last couple of years. So that is map. Let's do another one. And this one will be filter. So let me take everything that I had before, put that into my filter. Okay. And so the filter that we're going to look at here, very similar to what we had before, but like we had this if statement declared. So what filter could do for us is we could say something like items.filter, okay, give it a function. And then we need to return like a Boolean value, like true or false, or something that's truthy. So in this case, let's give it like the number 8. So what would all of those equal? Well, watch this. It's not like map where like all the items would now be 8. So it just returned every single item again, because 8 is truthy. So like watch, if I return 0, it will return an empty array. See, something like that. Here's a little pop quiz. What do you think an empty string is going to return? Let's find out. Pause the video if you want a longer time to guess. Ooh, yeah, falsy. Okay, so with that, filter, you don't need all of this other stuff, like these if conditions, like check this and also check this. Now, something to keep in mind is, like, let's say we're going to replicate this part. So here's the item itself. I say item.name is less than 0, right? Let me, This is what I would get at first. But let's say I want everything that's less than 0 and starts with a W, because that was what was in here. There are a couple ways to do this. You could do something like this, item.color.starts with, do W, okay. So that's the equivalent. So again, it's definitely shorter in lines, a little bit clearer. You don't have to index into the array to get those items. So let's just look. We'll actually get something that's empty because we don't have a color or a name that's below 0 and then the color starts with a W. This might look weird to do both of these conditions. Like this is what's known as like a compound condition. We have one condition and then a logical and or a logical or for the next condition. So some people actually do something like this. Filter again. Function. Get that item once again. And then we return item.color.starts with a W. Right? So what it'll do, it'll actually create two arrays. That's not quite the same as what we had here. We're only operating on just the one array. We're checking both things. So this is something to keep in mind, the differences of how you can actually construct these. So we have like this first filter, right? It usually looks something like this. Okay. Let's make these arrow functions. There we go. And then you have like a filter on the next line, right? That to me is a lot clearer to read than doing something like what's listed below. My implementation of how I like this, there's actually a trade-off for creating two arrays, filtering and creating one array, and then filtering and creating a second array of that subset of the filter. So essentially you would create one array here, return that, and then we'd have to filter that again and iterate through all those items in that array. So this is definitely like a more efficient way of looping through all the items. Or I can go back to just checking both of these things. Right? And that would be the equivalent of what I have here in like the C-style for loop. So filters are great. I would suggest taking a look at these two if you haven't already. And the reason you're using them, again, is to get rid of that initializer, the condition, and then the increment of the I or the index variable. So you don't have to worry about that. Pretty sweet. So you might think of the map as, if you're going to map over something, you're getting the same array count afterwards, or the same length. So if it had 5 things in the array, you map over it, you're going to get 5 things back. With a filter, you can get anywhere from 0 things back to all of the length or the counts. So in this case, it'd be 5 things back again. But you can also get any number in between. So those are the two small differences between the filter and the map. Let's move on to the next one. Now we're going to do reduce. So again, let's take all of our items we have from our C-style for loop, and let's break down what exactly we need here to do a reduce. Now, reduce in this case, there's a couple ways to go about this. I think it's probably the most challenging one to realize what it does at first. So let's walk through it very slowly. Let's say we didn't want to get like all the negative numbers, but we want to get like the sum of all these numbers. So like, let's say sum of name. Okay, so all the names, we're going to add them together. So what we would do, let's take out this if statement. So we wouldn't necessarily make a new array, right? We're not returning an array. We're actually returning like a reduced something. So in this case, it's going to be an integer. I'm just going to leave it like that for now. I'm going to say eventually this is going to be a number. So I'm just making a little comment for myself so I can remember that. So what I would do is say that this is equal to the items at index I. Okay, so we're continually updating this sum. Very similar to like this type of style of just like incrementing the index. Here we're actually like transforming the value of this. So what I would start with, you have to have some sort of initialization for this. I would say start with 0, right? Now it can't be a const anymore. It has to be a let. So these are a couple things you have to think about when balancing this traditional for style loop and you're trying to do like a reduction of the information you're looping through. So the sum here, let's see what it looks like. Oops, made a mistake. Where did I make my mistake? Oh, item instead of items. There we go. All right. So here, oh yeah, I didn't get the name, dot name. There we go. All right, so that's the sum of all of these numbers, 34 plus 24 plus negative 99 plus 100 plus 0 equals 59. So that's how we could do it in a traditional like C style for loop. Let's take a look at actually changing this to be a reduce. So let's take out these things here. And what we would do is reduce, and it actually takes 2 arguments to this function, right? Oh, items dot reduce. We first have the function, and then we have the initial value, like so, right? So if I was to do this for my first time, I'd probably do like item, okay? And then the initial value is going to be 0, right? Now, it's not just the item that we get passed in. We actually get passed in the previous, and then this is the item or like the next thing that comes up. You can actually see in the documentation here, it's previous value is what it's referred to. And now it's even giving us more IntelliSense from the editor that we're getting this object that has a name and a color, and so on. So there's a couple of other things you could pull out, like the index of what you're looking at too. So this would be like the index here, right? So let me just do this. I'm going to do console log, the index, and then we'll do the item, and then we'll do the previous, just so you can see like each iteration, like what's going to happen. Let me take out these last 2 down here. So notice the index was first, so that in this case is 0 to start, and then 1, and then so on. And we have our item itself, which is the object. And since it's the initialization of 0, the previous, on the first iteration, it is actually 0. But then since we don't return anything from this function, everything else is undefined. So we don't want necessarily undefined. We want like a new value from that. So if this is like the sum of all the names, what we would want to do is return whatever it previously was plus the item name, right? Now in this case, we don't need the index. Maybe you can find a use for that. In this case, we do not. So we're just going to keep it simple. We have a function that takes 2 arguments as the first parameter. We have the initial value, which is the second parameter. In that first parameter, since that is a function, we actually need 2 parameters with that one. So it's the previous value. So whatever this previous value is, on the first iteration, it's that initial value. Every other iteration, it's whatever you return. And then you have the item itself. So it's like looping through that array, getting the items, and then getting the sum of all those things. So if we go through this and we print this out, let's see what we get. 59, just like how we did before. So that is our reduce, but a couple other things you might want to do with reduce. You could actually reduce to like, I don't know, an object of some kind. So you can say like, let's see, I don't know, count. Oh wait, here we go. Sum is 0, and then like the min, I don't know. Let's just start with the min as -1, right? So the previous item we would actually return like two things. We return a brand new object where the sum is going to be the previous dot sum plus item dot name, right? Because that's our number that we want to get there. But then we want to get the min. So then we could say something like, if the previous dot min is less than the item dot name, we'll do a ternary operator here. We'll return the previous dot min. Otherwise, we will return the item dot name. Right? So the minimum in this case looks like it should be 99. Let's just double check that I did that right. Yes, the minimum is 99. So that's that reduce option that you have there. So the first example of just like getting one single value out of it, that makes sense. But then what if you want to iterate over everything and calculate through each iteration and update these values? This could be a very succinct way of doing this. You might think in the C-style traditional loop, we might have like a couple different variables, like a sum variable, a min variable, and all these other things. Or we make like an object and keep mutating that object there. It could get really tricky to make it look nice and make it look readable. But I think this is pretty readable. And let me, just for fun, throw in the arrow function syntax, which you see right there. So pretty minimal effort to get something like that up and running. When it comes to a reduce, it's a little bit easier to read like what's going on here and what it is you're trying to accomplish, because you have that initial value that's listed here too. And again, these are parameters on the map filter and reduce, so you can pass in new stuff, which is pretty sweet. So thanks for joining me today in this really cool lesson about map, reduce, and filter. Hope you can start using it in your projects and understanding the differences when it comes to like a C-style traditional loop. And have fun with this, experiment, try new things. If you have any questions or comments, put them down below. If you want to subscribe and you can see more videos of something like this, or you want to look at previous videos that I've done before, go ahead and hit that subscribe button. And I'll see you guys later.